Good morning, all of you. So here in this today's lecture, we are going to discuss about the FYBSc chapter number second, that is the calculations used in analytical chemistry. In previous video or previous lectures, we have already discussed about the some calculations parts, some units parts that units that like say percentage concentrations, then parts per million, parts per billion, and parts per thousand. This overall all concept we have already discussed in previous video. So watch this video and then next watch this today's video or lecture. So here in this today's lecture we are going to discuss about the concentration terms. There are the two concentration terms, that is the molar concentration and normal concentrations. So first of all, we are going to discuss here the molar concentration. What is molar concentration? Molar concentration is denoted by capital M. So here I will write capital M for the molar concentration. So the definition of molar concentration is that the number of moles of solute, number of moles of solute number of moles of solute dissolve in a 1 liter of solution. This is called as the molar concentration. So number of moles of solids, how to calculate the number of moles. In previous video we have already discussed how to calculate the number of moles and their formula. The formula for calculating the number of moles is that the given weight of the any chemical compounds divided by the molar concentration, molar mass of the given compounds, and the further calculations we have to getting the number of moles. So here the number of moles of solute that are dissolved in 1 liter of solution, this is called as the molar concentrations. For example, how will you prepare the 2 molar NaOH solutions? Then first of all write the standard equation for the 2 molar NaOH solutions, that for the molar concentration standard equation. The standard equation is that the 1 molar NaOH 1 molar 1000 ml 1 molar 1000 ml of NaOH corresponding to 40 gram of NaOH, Na plus. That means here, so 1000 ml of solution, that is the we have to taking a solvent or any solutions, that is the 1000 ml. Then addition to that solution 40 gram of NaOH, then this solution is a 1 molar solution. So 40 is what? 40 is, it is a molar mass of the NaOH. How to calculate the molar mass of NaOH or any other chemical compounds is already discussed in a class. So here this is the standard equation for calculating the any molar solutions. Then the question is that how to prepare 2 molar NaOH solutions. Then we have to write here the 2 molar 1000 ml of NaOH corresponding to how much gram of Na plus or the NaOH we have to taken. So here cross multiplying that 2 molar and 1000 ml, these are the cross multiply with the molar mass of the NaOH and against divided into the this quantity, that is the 1 molar and the 1000 ml of the solution. So here cross multiplication is that 2 molar multiply by 1000 ml and this again multiply by 40 gram of the Na plus ions and divided by this 1 molars and the 1000 ml of the solvent solutions, that is the 1 into thousands, and we have to getting this answer. So this 1000 and this 1000 will cancels, this 40 multiply by 2, this is the 80. So 80 gram of the NaOH we have to taken and add into 1000 ml of solution or the solvent, or also water. We have to must prepare the water as a solvent for the preparations of the solutions. This is the getting answer how to prepare that of the molar solutions. So again I will repeat that concept, that is the molar concentration. Molar concentration is nothing but it is denoted by the capital M, and this molar concentration is nothing but the number of moles of solute in a 1 liter of the solutions. And how to calculate this any solution or any concentration of molar concentration of any chemical compounds, this is the general method for calculating the molar concentration. So here some another examples we have to taken here. Example number 2, again I will take a standard equation for the calculating the molar concentration, that is the 1 molar 1000 ml NaOH corresponding to 40 gram of Na plus ions. So we have to calculate the 0.5 or the 4 molar. So or the calculating the 2 molar. Here standard equations required 1000 ml of solutions, but we have to take prepare the solutions is only 500 mls, 100 mls, 50 mls. Then we must change the ml of the quantity. We must change the different concentration for the different terms. That is the, for example, we are to preparing the 0.2 molar, then we have to take here 0.2 molar. If we have to preparing the 0.5 molar, then we have to take here 0.5 molar. So on the basis of that, what will required to prepare the solutions? If we have to required 2 molar 100 ml NaOH, then how much amount of NaOH we have to taken and diluted into the 100 ml of the solution. So here against the cross multiplication, here 2 molar and 1000 ml, these are the overall quantities is multiply. This quantity is multiplied with this molar mass of the NaOH, and this will divided to that of the solution. So here the cross multiplications we have to getting the answer, how much amount of NaOH we have to required to prepare the 2 molar of the 1000 ml solution. So 2 into 100, then 40 divided by this 1000 ml. So here both zeros are the cancel, then required available only 4 and 2, this 4 multiplied 2, we are to getting a 8 gram. So 8 gram of NaOH diluted into 100 ml of distilled water. So this is the preparation of 2 molar 100 ml NaOH solution. So the next concentration term is that there is the normal concentrations. How to prepare, what is the normality, and how to find the normal solutions by different chemicals or chemical compounds. Second point is that normality. This normality is a generally denoted by capital N. So this normality we have to find the best way. The first of all, the definition of the normality. Normality is defined as the number of moles of solute, number of equivalent weight of the solute per liter of the solutions. That means number of equivalent weight of solute in a 1 liter 1 liter of solution. So this is the basic definition of the normality. So here we have to take in one example of the normality. For example, we required to prepare the one normal solution, one normal one normal of NaOH solutions. We are to taking only NaOH solutions. If we are to taking another chemical compound, then another chemical compounds we have to require the molar mass of the another compound. So for example, we are to taking a HCl, then we have required the normality of the another compounds. For example, we are to taking a NaCl compound, then molar mass of the NaCl compound. This is the most important, because one normal 1000 ml NaOH corresponding to 40 gram, but one normal 1000 ml NaCl contains the 56 gram. So molar mass is the difference. Then changing the chemical compounds, we require the change chemical compound molar mass. Okay, so one normal NaOH prepared in 100 ml of the solution, 100 ml distilled water. We have to performing any practicals or any project, we must require the solution preparation part is the very important part. So we must know that how to prepare the chemicals, different chemicals, that is the normality, molarity, parts per million, parts per billion, percentage weight by weight, percentage weight by volume, percentage volume by volume. These all the concentration unit as are most important. So here the required calculations for the preparation of one normal NaOH in 1000 ml distilled water. So I will write here the standard formula or standard equation for the normality of NaOH or normal solution. So one normal 1000 ml NaOH corresponding to 40 gram of the Na plus ions. So we required here one normal, so I will take here one normal for 100 ml. Here standard equation for the 1000 ml, but I here requirement is that 100 ml, so I will put here 100 ml NaOH corresponding to how much gram. That means here one normal 1000 ml NaOH is this normality here taken 40 gram, but here one normal 100 ml, how much gram of that NaOH requires to dilute the solution. So here cross multiply with that solutions, this one normal and 1000 ml, this cross multiply with 40 gram and against divided into one normal and 1000 ml of the solution. So here we calculating this part, one normal into 100 ml into 40 and against divided into 1000 ml. So against this two zeros cancels, this one zero cancel, and this 4 into 1, here only 4 gram of the NaOH use and dilute with 100 ml of distilled water. So this is the preparation of one normal NaOH solution. So similarly we are calculating the different concentration term by using different chemical compounds. We must require the molar mass of the different chemical compounds. So we are to taking another compound, then we must require that another molar mass of that compound, specific compound. So here another one concept is that here definition of the normality is that equivalent weight. What is the equivalent weight? So equivalent weight is that molecular weight of any compounds that divided by their acidity of that chemical compound, basicity of that compounds, and oxidation state of that compound. Here some compounds, for example, we have to taking here KMnO4 compound. The oxidation state of KMnO4 is plus 7. So we must required to divided that molecular weight of KMnO4 by 7, and we have to get that number, that is the equivalent weight of the KMnO4. For example, we are to taking a uh, sulfuric acid having a basicity is 2. That means here 2 H plus ions are available to dilution of the chemicals or the equilibrium with the chemicals. So we can divide it into 2 for that molecular weight of the sulfuric acids. We have to getting a equivalent weight of the sulfuric acid. So as similarly we have to calculating the equivalent weight of the different chemical compounds, but we must know that their basicity, acidity and oxidation state of the different chemical compounds. For example, this is about the solid compounds, how to prepare that solid solutions in different concentrations. So here we are taking one another example of the liquid compounds. How will you prepare that different liquid compound concentration terms? So for preparation of the liquid compound solution preparations, for example, we have to prepare the one normal HCl solutions for the 500 ml, one normal HCl solution for 100 ml in distilled water. We have to prepare one normal HCl solution in a 100 ml distilled water. Then how will you prepare that solutions? The solid solution preparation concentration term is different than liquid concentration term. So here we must know that there is the N1 Phi1 terms. N1 Phi1 is equal to N2 Phi2. What is that N1? What is that N2 Phi2 V1? This is the different terms. That is the N1 is the normality of the compounds. For example, here normality, then we have to take here normal. If here there is the normal molar, then we have to take here M1 and M2. So there is the depends on the what type of the questions we have to getting, and so answer of that questions we have to finding out by using this formula, that is the N1 Phi1 and N2 Phi2. So here we find out the volume of HCl, how much HCl we have to required to preparations of one normal HCl solution in 100 ml or distilled water. So the normality of HCl is actually gaseous compounds that can purge into water and dissolve in a water solutions. We are to getting only 30% of the HCl's diluted into the water. So the percentage purity of the HCl is only near about the 30%. So the normality of equivalent weight of the HCl is near about the 11.5, or normality, sorry, not a equivalent weight. So normality of a HCl is near about the 11.5 in a general normal temperatures or the normal solutions or the normal concentrated HCl solution. So here the normality we have to put here N1. N1 means what? Normality of the HCl compounds. So here taking a 11.5, the volume, we find out the volume, how much volumes we have to require to prepare the one normal of the HCl solution. Then next is the N2. N2 means what? There is the required normality, find out normality as per the question. So here is the one normal. Then volume, we have to preparing how much volumes for that, there is the 100 ml. So we multiply by it a 100 ml. So then there is the finding out Phi1. It is a very simple calculations for finding out the Phi1. So it is equal to 1 into 100 divided by, there is the 11.5. So we getting a answer. Further calculations we getting a some answer, and that answer is that for the calculating the one normal HCl solution. For example, this answer is getting a somewhat uh, 7, near about 7 about. So this is the 7 ml we have to taken and dilute into the 100 ml distilled water. Then this is the preparation of a one normal HCl solutions. So this is the related to the liquid solution. Similarly, that preparations of the solids we have to already discuss. This is the liquid. Then another one example we have to take for the calculating the normality or the molarity of the solution. So another example we have to taken here, that is the, for example, we have to prepare the 5 normal of acetic acid in 500 ml distilled water. How to prepare, how to calculate this? We know that the normality of any chemical compounds, we have to must know that. So HCl is the 11.5. Similarly, acetic acid, the normality of acetic acid is near about 17.5 or 70, 17.5. So we have to calculate it by using the N1 Phi1 is equal to N2 Phi2. So here is the normality is the 17.5, then find out the Phi1 is equal to N2 is the normality in equation, and Phi2 it is the volume that required to prepare the acetic acid. So here we getting an answer, that is the 5 into 500 divided by 17.5, and further calculations we get an answer, and this answer ml of that quantity we must dilute it into the 500 ml of solutions, and this is the preparation of 5 normal acetic acid solution for the 500 ml of the distilled water. This is about the liquid and solid component, how to prepare that liquid solution, liquid concentrated solution and solid concentration solution. This is the very important for all the chemistry students, because it is a very basic thing. So we must know that how to prepare the concentration or the solution terms. So thanks for watching a video.